Hey guys, this is Mr. Fourth Dimension, and welcome to an episode of the Geo Project. Gonna start doing a few things with ellipses today. Before we get back in and can do all the sorts of stuff we have to do with triangles, I just felt like stopping to do the ellipses because we have the machinery now to do the various things I want to do, except maybe one thing. But I think it's worth it to get started now. So, just to kick it off, following the pattern we did for everything else, we'll do area stuff. So, geo ellipse. Now the question, of course, is how do you want to define your ellipses? The standard geometric formula for an ellipse is 2 points, called the foci, and the radius total, or something like that, if you want to call it the fixed sum from those 2 points, of distance from those 2 points. And I've been thinking about it, and I don't see any reason why not to use that as one of our starting places. So that's what we will do. It'll take 2 points. Focus 1, geo point, come on, focus 2, and then R sum, something like that, right? Now, how do you compute an area on something like this? Well, what we actually need to know to find an area of this is we want to know how long its longest axis is and its shorter axis. I should draw a picture of this. I'm going to see if I can pop open Paint. Alright, cool. Hopefully this will do. So, let's say we have an ellipse, and say it's sort of, ooh, that's bad, sort of roughly shaped like this, right? It's going to be a really rough ellipse. Jeez. Let's try that one more time. Come on. I don't have a good mouse situation here. It's one of my problems, and I'm trying to draw this with a mouse. Come on. Like, I'll move the mouse and it won't actually move because my mouse pad's not really a mouse pad, it's a notebook. If I use the trackpad, it's not necessarily that smooth either. Anyway. So it's sort of like an elongated circle, and you can say it has a real center somewhere. And then it has a short radius and a long radius. Whoa. A long radius, right? And if we know these two radiuses, then we can compute the area of an ellipse by doing the same thing we do for a circle, which is the radius squared times pi, except instead of squaring the radius, it's the short radius times the long radius, because basically you take the area of a circle as if both of them had the same, like you imagine that they were both the size of the short radius and you just had a circle, right? But then you say, oh, but my long radius actually elongates it by double, right? So you just, instead of multiplying by r min, it's just r min times r max times pi. So we need to find a way to compute these two values. But if we're going to represent it as 2 points, that's going to kind of be a problem, right? So let's see if we can maybe compute it first with a different representation. Another representation could be geo ellipse area, a center point, a major, or we'll call it R min or R minor, and 32 R maj for R major. And then the other thing you would need to define an ellipse this way is your ellipses aren't necessarily axis aligned, right? I want to do general ellipses. That means the foci might not be horizontally and vertically oriented. They might be shaped more like this. Oh, that's getting even worse. There we go. That's pretty rough, but it works. Right, so we might have an ellipse that kind of goes diagonal. So what this representation actually also has to do is tell you what the angle, the direction, the 2-point sort of direction of that of those two foci has to give you this angle so you know how your ellipse is oriented. So it's a little over-defined because you have a center, I'm not talking about the two foci, if I have a center, a major axis, a minor axis, and then the angle of the major axis, so it takes 4 pieces of information to define it that way, whereas it takes 3 with this, the 2 points and the sum radius, but it's more useful in some cases like when we want to find the area. But for finding the area, we don't actually need that angle. It doesn't matter what the angle is. So, and for that matter, it doesn't matter what the center is. So to find the area of an ellipse is just a matter of the two axes. So then, as we discussed, it's r min times r major times pi, right? Now, the real question is, if I give you two focus, or if I'm given two focus and the sum of them, how do I find those? Well, for one thing, let's go back to the, I don't have it anymore. Let's go back to this sort of ellipse. Yep, that's too rough. Too rough. Here we go. Gonna nail it this time. Gonna use the other mouse. And oh, that's not great, but there we go. So if I want to find, here's my R min, here's my R max. Oops, something like that, right? If I want to find the R max, then that's the point that's all the way to the right, and if I didn't have these weird artifacts in my terrible ellipse drawing, then what you would have is this length here is always going to be half of the R sum, because it's the average, it's the center point between, if it's coming from the center, that means it's between these two foci. So the distance from there to there should be, when they're all collinear, the center and the two foci and the edge that you're, the point on the ellipse, when they're all collinear, then its length should be the average of the other two. So that's R1 plus R2, right, over 2. Jeez, oh Pete, I'm going to have to find a better way to do these diagrams if I'm going to keep doing them. But that is just the R sum, which we use to define the whole ellipse over 2, because R1 plus R2, if those are the two distances from the foci, the sum of them is how we define the ellipse in the first place. So we take that whole sum divided by 2, that's the major axis. So that's solved, right? We can just do return geo ellipse area R sum divided by 2. So that's nice. Maybe do you think we can get away with not needing the foci for this one as well? The answer is no. That's what the foci are there so that we can figure out that part. So, well, I want to redo those. Can I redo? Okay. So how do we find this short area here? We have to use some triangle. So I'm going to switch to a different color to draw in this triangle now. We have this triangle here, which those two things, those two leg lengths, should both be equal when it's this particular case. This is the case where those two are equal. So R1 equals R2, and for that to be possible, they both have to be R over 2. Right? So these lengths both have to be R over 2 for this to be possible, so that they add up to a total of R and are equal. If that's the case, then we know these leg lengths, or these side lengths of these triangles. And then all we have to do is we have to ask, what is this length here, this here, and we can of course make this into a right triangle. We know we can find the length of either of these, because these two should be equal, because we're drawing this from the center up, so these should be equal. So that's just the distance between these two things divided by 2. If I take the distance between the foci, divide by 2, I get this length, and then I have all I need for Pythagorean Theorem to figure out that. So let's see, that's the distance between the foci is geo distance focus 1, focus 2, And then if I divide that by 2, I get the length of a short leg. And then if I do okay, so if I do the Pythagorean Theorem now on this leg length here and this length here, or this leg length and this hypotenuse, I guess is the term that you use at this point, because we're going to use like half of this triangle, the right angled part, then we can find this part here. So the actual equation is that r over 2, if I square that, this is so rough, the penmanship, it's crazy, plus b squared will equal, no, I got that backwards, that will equal b squared plus that right there, which is a squared, right? So the b will just equal the square root of half r squared, there we go, plus a squared, or minus a squared. It's kind of hard to think and draw these terrible diagrams at the same time. Okay, so that is the minor axis is the square root of half of that squared, and this is rough first pass, and maybe we'll have to clean this code up because it looks like we're squaring something that we're dividing by 2 twice, which isn't cool. And there's probably a way to do it without having to divide by 2, since we're also dividing that dist, which is actually the a, by 2, so maybe we don't have to divide by 2 once out of all of those. Once we've taken that square root, is there anything else we had to do? No, that should be the minor axis, right? Is there anything we're missing here? Squared? Oh, we gotta square this. Alright, so yeah, that seems right. That should find the area of an ellipse given the foci and the the standard definition, the r sum here. So let's mess with this a bit. First we'll test out the easy version. Geo ellipse area, and we'll do an R major and minor. So the minor we're assuming that that's going to be smaller than the major, so we'll do 3 and 6, so it should be twice the size of a circle whose radius is 3, right? And then we'll do print hopefully it builds. I think it will. There we go. Alright, so let's check that out. 56.548664. Divide that by 2, we get this. Now we said it should be half the area, so that's how we get back to the size of a circle with the radius 3. Divide that by 9, we should get to pi, and we do. Alright, now let's do the other one. Right, so we have to define 2 points to be the foci and the total sum radius. So one thing we could do is we could say that we're going to center it around the origin like so and give it a radius of about 6. Now that doesn't mean that its major axis will be a 6, right? That actually means that the major axis is only a 3, so this isn't the same one we just did. And it would take some computation and it'd be a weird result if we wanted to do the same shape we just did. So there's no great way to make sure that that's right, but it seems about right because it is about half, which is about what it should be. Depends on what that minor axis is computing out to be, I guess. But we'll have to test it more thoroughly next time by coming up with a plan and looking at ellipses whose areas we know. One other thing we could do while we're here is real quick put these both at the center. Actually, that wasn't, I put that one in the wrong spot. I meant to put it here. Anyway, yeah, we'll definitely need to test this correctly. But let's say that we put both foci in the same spot. See if that result makes any sense. Because if not, then that's a problem. Because when both foci are in the same spot, it should give us a result like a circle of radius 3. Is that a circle of radius 3? I don't think so, because a circle of radius 3 should be at least 9. So it looks like we've got some debugging to do on the ellipse area next time. Alright, so I'll see you guys then.